Welcome to the first episode of 2022.
Happy New Year! Woo! It's a
Happy
brand
New
new year.
Year.
Putting the I in I am Nano. I'm your host, Irfani.
And I'm your other host, Monica.
And today we're going to be talking about those shiny rocks that a lot of people like, diamonds.
Yeah, very expensive shiny rocks.
Yes.
And it seems like carbon elements take up quite the spotlight on our show these days.
Yeah, that's true.
But these diamonds are actually very special, still made from carbon, but they start by crushing buckyballs or Buckminster fullerene.
So this new form of diamond is actually made from nano soccer balls, if you will.
Yeah.
And it also has the name of C60. And interestingly, it has similar properties to regular diamonds. So it's shiny, strong, but it also withstands heat a lot better. So these new diamonds can be used in tools that operate at very hot conditions.
Yeah, exactly. And now these diamonds are still made under pressure, quite a bit of it actually. So 30 gigapascals at least. And for context, a pressure cooker is only about 0.0001 gigapascals, and that's enough to cook your meat and vegetables, make a nice little soup. And I should add, at the bottom of the ocean, at the very, very bottom, you can get to about 50 gigapascals. So that's on the scale, of the 30 gigapascal range. So that is a lot of pressure.
That's a lot of pressure. And for context, a naturally formed diamond is about 5 gigapascals minimum. And you want heat with buckyball diamonds, as you do with naturally formed ones, at about 1,200 Celsius. And so that is over 2,000 Fahrenheit.
Very, very hot.
Very hot, super hot.
Pressure. It kind of makes you feel like exam season.
Yeah.
I guess. Yeah. Now, there are actually two main types of molecular structures with diamonds and other materials as well. And that would be crystalline, which means that all the atoms are neatly organized and in repeating arrangements. And then there is the amorphous structures that are mostly disorganized and kind of all over the place.
And in this lit update, the researchers from George Mason University in the US, University of Bayreuth in Germany, and two high-profile Chinese research institutes managed to come together and identify the existence of a diamond that has a structure between the crystalline and the amorphous state for the very first time.
Right, exactly. And in this new form, it's called paracrystalline diamond, which conveniently, the title of the article itself is The Synthesis of Paracrystalline Diamond. What do you know? And this is found in the Nature journal, but it is actually viewable for free. So, and that's thanks to something called the Shared It program. So you can start off this year right with learning all about this new form of diamond freely available.
Ooh. So what is different about paracrystalline diamond? Well, it means that this new diamond of small structures have just a few carbon atoms without any particular order in their arrangement, completely different from the very, very crystalline structure of a natural diamond.
And this intermediate state, if you will, is currently the first time it's observed. And that is why it's a Nature paper. And it could very well be present in other materials, but other scientists just have to find it.
Yeah, so that's really cool. And is there anything else interesting about this paracrystalline diamond material?
Well, it turns out that it is actually more stable than other forms of diamond at high temperatures. And another thing to think about is that this C60 form diamond can be used in industrial tools where you need a lot of longevity and maybe long-term use at high temperatures, so very, very high temperatures. So I guess welding would be a good application for this. I would also think maybe electronics, but it also depends how cheaply we can make this material.
Right. And it's hard to imagine like a high pressure, high temperature environment to easily create and mass market the Buckyball diamond. But I'm sure that once that hurdle is handled, it can be very, very promising. And another thing to mention is that 6 ultra-hard carbide anvils were used to create that environment. And it's a thing that the Wile E. Coyotes tried to drop on the Roadrunner on Looney Tunes.
Oh,
That's the
what an
anvil.
is.
Yeah.
Got it. And those can be, I guess, quite difficult to acquire.
Yeah, for sure.
And I also want to mention that computer simulations were also completed to verify the existence of the paracrystalline state. And this was also confirmed in the experiments through X-ray diffraction, so XRD, and high resolution TEM, so transmission electron microscopy.
Yes, it's really cool. It's always important to get the simulations in.
Yeah, for sure. And they are everywhere now. Not a bad thing, but certainly a learning curve if you want to do them yourself. And, maybe that'll be my New Year's resolution, learn something about this computer modeling stuff. But you have to keep me accountable for that, Irfani, and the viewers too, and the listeners.
Yes, I will keep asking you about that. The computer simulations are really important. They're powerful mathematical tools to confirm our findings or, test for conditions that can't be done in the lab. And also they're helpful to demonstrate chemical reactions for, just study purposes.
Yes, chemical reactions. And I'm glad you mentioned that, because I wanted to add that the crystalline formation of these new diamonds was because of densely distributed sites of nucleation that were developed in the compressed buckyballs. And that was due to the strong sp2 or double bond interactions.
Yeah, nucleation is that very first step that happens when a crystal is being formed from a solution phase.
Yes, it's very interesting that it happens in between the bonds by crushing the C60. But also one point is that the color of these newly formed diamonds look just like the regular item.
Wow. So I guess diamonds could be a computer chip's best friend in the future, eh?
Yeah, I think so.
Yeah.
I think that's a great way of putting it. Yeah.
Yeah, and I know that there's a lot of things happening in the world that's not really great, but hopefully we can all have a very diamond of a year, shiny, wonderful thing of a year.
For sure. I hope so too. And as we have discussed, diamonds can be formed by all types of different carbon starting materials, it seems like. And, sometimes we can get good things from something unexpected. So just keep that attitude.
Yeah, let's keep our heads up, look at things a bit more brightly, hopefully within this very grim situation. Okay, that took a doctor. Anyways.
Okay.
Anyways, that is all the Nana for today. Take care.
And stay curious.